So get ready, folks. Got those name cards out today. What's happening? It's happening. All right, so PS19B, you only have to do like 3 questions from that. So I'm assuming you got those done, and then PS19B will do on Monday after you have accomplished titrations. It's just stoichiometry, so it's not like we're learning new stuff. It's just applied in the setting of acids and bases. Just like the reactions we did yesterday. What were the 2 types of acid and base reactions we did yesterday? Hydrolysis and neutralization. Was it really new? It was just what? Double replacement. So again, nomenclature is back in, ionic crisscrossing of charges is back in, and now we're utilizing pH. It's just a mathematical formula. So again, it's just like kind of reframing things around acids and bases. All right, Colin, phosphoric acid. Formula, let's go. H3PO4. Good. I kind of told you guys how to do that in reference to the conjugate base. Remember, the conjugate base comes from the acid after it has deprotonated or after it has lost one of its protons, aka an H+. Marlena, what do you think? So make it lose an H+. H2PO4. So when it loses an H1+, it's neutral in charge here. There's no charge. When I lose an H+, what does it have to become charge-wise? -1, okay? Make another deprotonization occur. So drop off another H+, Jaden. H, so now we're down to 1 H, good. PO4, what? 2- because we're going down in charge even more. And that's just the process. It's a very sequential process. Oh dang, Audie's not here. Who's Audie's buddy? They have a key, it's whatever. Audie's buddy. Okay. They have a key. They have a key. Okay. Michaela, next. Yay! Okay, and what does everybody recognize that as? Yay! Hi!
I'm just getting some B-roll for our digital lookbook.
Okay.
She's not coordinated, she just happened to bring me.
Okay. I taught both his kids. So.
And while I'm just graduating,
we have a good relationship. Okay. So you guys act normal, just as goofy as whatever, okay? So, are we good here? Conjugates. Okay, so stuff with acids and bases. Send me a partner, give me a table partner, and come grab a lecture sheet, okay? I'm going to pass out little handfuls. Pass them by me. Alright, grab an extra for your buddy. If you didn't grab one. Extras are right here. For you, one for your buddy. There's extras. Paige, we pass one. Yeah. You're okay. Sit with me and work through what you can, okay? All right, so some of you guys who were here yesterday, you remember, what's the name of this indicator again? Good, phenolphthalein. This is part of it, right? All right, so phenolphthalein, it turns what color in base? Pink. Okay, so what pH does that generally start to turn pink at? Yeah, around 8, 8.5, 8 to 9-ish. So when we do our titration on Monday, we're literally setting this up. Okay, so this equipment's a little bit fancier than normal. So I save it until you're like no longer Butterfingers at the end of the semester. So this guy right here is called a burette. You want to write this down because you're going to draw this eventually in a simulation that we're going to see shortly, okay? So the burette is a long piece of glassware, about this long. It's like $95. And there's this little piece on the bottom called a stopcock. Yep, they chose to name it that, okay? So the stopcock is going to twirl, and it releases just volume by volume by volume. So we call this whole process of titration, but it's really something called volumetric analysis. Okay, so what does it kind of sound like we're doing when I say volumetric analysis? Say again? Well, what am I doing with the volume? I'm analyzing something about it, okay? And with that, I'm going to be actually calculating concentration. When I say concentration, what unit do you think of? Yes, molarity, good. So it all kind of brings back stuff from, what, a week or two ago? So as we process this, we usually start with what's this called? Yes, this is a flask, and in the flask we're going to have a solution. And that solution is actually an unknown molarity, and that unknown molarity is our job. We have to figure out what that is. So as we titrate, we're dispensing volume by volume by volume in here. Well, it's clear, 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 and if we don't put an indicator in there, it's going to continue to be clear. So we would never know anything's happening. So what do we add to tell us something is happening? We add phenolphthalein. So we have the phenolphthalein, and it says, oh gosh, what's adding pH? I know people here yesterday. Let's go. It's above? 7. Okay, I'll say above 8. I was good with that, because phenolphthalein specifically changes around 8. So as you go and you add this clear solution, then this indicator starts to turn pink. It's telling you the pH is increasing. And then you know, just more information. Actually, we start to graph this, we can do calculations and so forth. So at this point, when it's like Barbie pink, it is too far. That means you have to start the whole process over because you've gone too far. So that's why it's a little bit of a rigorous procedure, but we're going to do a simulation today. Make sure you can do the procedure and the calculations. Yes, sir. Because there's a point called the equivalence point, which we're going to see on a graph. And if you surpass the equivalence point, your volumes are incorrect. If your volumes are incorrect, then you've gone too far. So the indicators just tell you when to stop, and that's what my next slide is. Okay, you good? I have no idea what that was, guys. What happened? Okay, huh? I don't know, because I was like, why do they have a camera on me? Even though I just videoed myself like with you guys a million times. I didn't. So, okay, so this whole process, we can graph, and that graph looks like this, okay? Take a moment, you see the L graph on your paper? Okay, give yourself a quick sketch. It does not have to be beautiful, but try to note some key points that I'm going to specify here with you. So key point number 1, you have your pH curve, right? So it's pH on the y-axis. And this pH curve is also going to give us the volume, because it's volumetric analysis, right? So we're going to also include the volume of whatever we're adding. And in this case, this graph is showing us adding sodium hydroxide. So this is on the paper I just gave you. Or your part. Okay. All right, so we got our axes labeled. And as you can imagine, the pH is going to change over the course of this reaction, over the course of this process. So in the flask, we're going to actually have acid. I told you just a solution earlier because it can vary, but if I'm titrating with a base, and it's an acid-base reaction, the acid must be in the flask, and the burette thing must hold the base. Okay? So why is the pH down here? What is this measuring? Is it measuring the one in that flask or the one in the burette? Yes, the flask. So this is our acid. We're starting at pH 1, so it's definitely acidic. So obviously what's happening is I add base over the course of this time. What's happening to the graph as I add a base? Okay, so, well, as I add the base, yeah, the volume of the base is increasing because I'm just adding base, but what do you see occurring because of that? The pH is getting more basic because I'm adding base, right? And it totally makes sense. So as I add base, pH goes up, and then it shoots up, and that's because of the logarithmic relationship, because when you graph a logarithmic relationship, it kind of, even if you invert it, it's going to have an exponential growth curve. So that's kind of what that's indicating. So in the middle of this vertical section, put a little circle or a star, and we're going to call that the equivalence point. Okay, equivalence point, and we're going to write down the definition of the equivalence point because we didn't do the reading guide, so I'm trying to pepper some of that in here now, okay? So, the equivalence point is where the moles of acid equal moles of base. And that is like the stoichiometric equivalent point. That is the perfect point that we run our stoichiometry based off of. So in a question, it'll say, blah, 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 15 milliliters were used to get to the equivalence point. So they're trying to tell you, like, it's a really important value. So, and that's about halfway up this vertical section here. At this point, I mean, you can read the graph. What's the equivalence point pH? 7. And that's simply because we're adding a strong base, sodium hydroxide, to whatever strong acid I had in my flask. The strong and strong scenario is going to meet in the middle at 7. So anytime you titrate a strong acid and a strong base together, they'll always have the equivalence point at 7, but the volumes will change. You can see I'm just dashing down. The volumes will change based on like what kind of molarities and concentrations and so forth we're using. Okay, so do you guys see what point the phenolphthalein color change is occurring on the graph? Starts changing around what? It's like really close to 8 and it'll hair above it. So what we really want is to choose an indicator that's perfect, that is actually going to start changing color at the equivalence point. Well, did we choose appropriately here? No, but it's what we had to work with. It was the best thing we had. There's lots of indicators like bromothionyl blue changes around 7. That would be better for this experiment because it changes right where the equivalence point is. But we have to work with what we have. And so the point at which color changes, indicator color changes, that's going to be called the end point, because it's literally telling you to end the reaction, end the titration, end the experiment. Because we can't see this clear stuff. We can't look and go, okay, how do I know when moles equals moles? You can't see the moles because they're all clear, they're all in solution. So we put the indicator in there to say stop the reaction so that we don't over titrate. Okay? So of course this one's really, it's not terribly off, but we could definitely narrow that gap if we needed to. And then this graph just completes itself just to show you how it looks in the end. What pH we're kind of ending at on here? 12-ish, and that's pretty basic. And that's because we have some acid here, we have some base, so it's not going to max out at 14 because that would be only base present, so that acid pulls it down a little bit towards pH 12. All right, so this is called a what? Titration curve. Okay, it's called titration curve. 2 key points are what and what?
Endpoint and equivalence point.
Endpoint and equivalence point. You should know the difference between those, okay? All right, so we're going to do some stoichiometry from this. Once I do a couple, you'll get the hang of it, but we're going to analyze the questions together first. We got that. Okay. Don't worry about this yet. This was like me talking through the problem-solving process. If I gave you X, how do you get to Y? But you guys are really good with understanding units. The whole purpose of stoichiometry is to do what? Convert by using unit cancellation all the way through. If you can cancel units, you're good. There's no questions on that. You can do that. But I'm going to walk you through a couple of those just to make sure you're good with that. So we're going to read this question together. This is on your paper, so feel free to write on your stuff there. So a student titrates 20 milliliters of a sample of a solution of hydrobromic acid. The titration requires 20.05 milliliters of 0.1819 molar sodium hydroxide solution. What is the molarity of the HBr solution? So in reading that, 1, you know it's a titration, so you're kind of visualizing what's happening. 2, you should realize that it's a reaction. We have a neutralization reaction occurring. And that is the very first step you must recognize. What's the balanced equation? Try to write it out first. So try to write out your reaction first. There's only 2 data points where the chemicals provided you there. All right, give me one reactant, Lindsay. HBr, hydrobromic acid. Allison, give me another. NaOH. Jacob, give me a product. Sodium bromide. So that's a 1 plus and a 1 minus on all these so far, so there's no really crisscrossing going on. Amari, last product? H2O, okay, yeah, don't think too hard. All right, so I am still going to write that as HOH. All right, everybody's balanced? It's good, right? Okay, so now we have the neutralization reaction recognized. Now we can start to talk about each component of it. All right, so I think it's super simple if you write the data underneath where the data or who it applies to. So student titrates this. Well, who is that talking about? Okay, so 20 milliliters, 20.00 milliliters. We do want to include the zeros because it's a sig-fig kind of relationship. The titration requires 20.05 of a 0.8 0.1819. Where does that belong? Sodium hydroxide. So we're going to put 20.05 milliliters and 0.1819 molar here. Who's the question asking about? Say again? Hydrobromic acid. It's asking about the hydrobromic acid. So put question mark, molarity. Okay, so I wrote the VCE and data out. That's kind of that's usually my first step. And then the idea is that you're identifying who we're titrating, so we call it the titrant, and who we're analyzing, meaning we call it the analyte. It's just special terminology. It's not that important, truly. So I'm going to rephrase this as known and unknown, because that's kind of the stuff we've been using in the past. So who's the known? Who do we know everything about in terms of the reactants? Sodium hydroxide. So you will always start with the known, which is also known as the titrant. Because you can't start with the question, because then how do you solve the question if you don't know everything you need to know? So we're going to start with the titrant, and then we're going to question ourselves or analyze the analyte, meaning the unknown. So we're going to use all this data, and we're going to start the process of stoichiometry. That's it. We'll use this data at the end because that's what the question's asking about. So again, what's molarity? Capital M, molarity. Moles per liter of solution, right? So moles of whatever per liters of solution. So if I have 0.1819, what does that really mean in terms of the fraction? 0.1819 moles, well, in NaOH in this case, right? Over 1 liter solution. So I'm here in liter, like after you said it 3 times. Do I have liters? No, I'm in milliliters. So what can I do with that to make this work? Okay, so how many liters is that? You guys can do it in your head. 0.02005 liters. Okay. So check we've used that data point. We can't use it again. And so now I have molarity. Write that out as it stands. What should it be? Top and bottom? What am I writing on top? 0.819 what? Moles of who? Good. You have to write the identity, because at this point we have sodium hydroxide, but the question's not about sodium hydroxide. So I don't know if I'm talking about moles of this guy or this guy. So do write the identity down. And that's per 1 liter of solution. All right, that's good. Liters cancels. Moving on. Nobody cares about sodium hydroxide, right? What do I care about this question? HBr. Actually, how do I get from NaOH to HBr? Right. Which is what in here? Right. So I know it's 1 to 1. You're like, that doesn't change my numbers at all. But it's really a good practice to always include, because if the numbers do change, you're going to forget to do it if you don't do it all the time. So now I'm going to put what on the bottom? 1 mole of sodium hydroxide. Thank you. And top? 1 mole of HBr. All right. So we're really close to the quantity molarity. Again, molarity is moles per liter. Currently, what unit do we have? Just moles, right? Because these moles of sodium hydroxide have canceled. So if I have moles on top, how do I get to molarity? What other unit do I need? I need liters, but where do I need it? Where? I need it technically on bottom, so I want it to be moles per liter, right? So this is where you can either opt to stop the calculation, just stop it, do your moles, and then separately divide by these liters. Or, if you understand that stopping and dividing is the same as multiplying by the inverse, I'm a fan of just multiplying by the inverse, because I don't have to calculate twice. So I can do 1 over what here? Good, point, what? So you're bouncing that back 3 times, so that's 0.0200 liters. So this is the same thing as either stopping and then dividing, or just multiplying by the inverse. It is the same process, so don't, if you want to do one or the other, it's totally fine. Calculate, guys. Give me a calculator, go grab one. And cancel yes and so forth, so you're good to go. Only units remaining are moles and liters. point 5. Oh, 3 to 5. Okay. So I can't get the full one first. So this is what Ashley got. Can I get a second? Okay, so we got this. How many significates do I need to check the data? Look at the data. 4 sig figs around that. 1824 molar HBr. Okay. So it's just reactions and stoichiometry. It's just in the phrasing of a titration. When you look at titrations average, like I don't know what this is, but now you understand some experimental procedure. Give me a thumbs up if I can move on to the next example. All right, so what are your 3 steps? Kind of 3 steps we work with. Read the question and do what? Okay, so hold on. Start by doing what, Jade? What did you say? Okay, so determine the reaction. Okay, so when we determine the reaction, we also are writing what underneath the reaction? The data, just so it's clear, like what data belongs to who. And then from there, you're finding the amylate and titrant, who do we actually start the stoich with? The known, aka the titrant, the one we know everything about. Okay? All right, go. Look in your table group, talk out loud. I'll just talk about some formulas if you need it. It says vinegar has acetic acid in it, so you're going to acetic acid. Go ahead. I'm just going to let everybody take their time on that first practice on their own. All right, and let's just check back up here. Check in with me. Give me a thumbs up if you started with the titrant of sodium hydroxide, 0.0227 liters. Keep going, thumbs up. You use molarity, which is moles per liters. What canceled? Liters, good. And then moles of sodium hydroxide. We don't care about sodium hydroxide, so what do we use next? 1-to-1 mole ratio. Remember, we always have to use a ratio no matter if it's 1-to-1 or not. And that's canceling out moles of sodium hydroxide. And then the C2H3O2, so acetic acid, needed to be moles per liter. So we stacked that appropriately to get to concentration, aka molarity. And what's our answer here? 8323, because there's 4 sig figs the whole way, right? You gotta look back at the data. If you wrote down like not 4 sig figs the whole way, then it's just because you didn't write the 0 or something. All right, let's jump to a slightly different one. This one was very much the same as the first, because in the end we solved for what? Molarity. Let's solve for a volume one. Let's go to 2 on the other side. That's on the right hand side. I'm gonna leave that there for anybody who still needs to work with that. Go ahead and try out number 2 on like the additional practice. So you guys are going to do 2 and 3 on that side, and I'm going to ask for a couple of you guys to get your laptops. So we've been trying to be there soon. Here, let's see, you just grab your laptops and you guys are just getting your computers pulled up for me, but you are going through questions 2 and 3. You might need a Xerox table if you don't remember which one. all of these are titrations. Anytime they're in a masochist reaction, the volume similarities always, it may not say titrations, but it's an experimental procedure. Once you finish number 2, you can check number 2 on the board and number 3 on the board. But I want to see working through 3 in the next couple minutes because I want to see if you get started on one your own. Did you put it there?
I'm really tired. So first thing life goals for you in class, but you get it with this.
From leaders to moles and moles to instead of leaders being on the bottom.
I mean, it might be. It's the same numbers. Well, I just have the right answer. It's just a lot.
The exact same thing that did the last problem. So I can go from the leaders and the HCL. I didn't know that it took
All right, let's help each other out a little bit. Some of us are progressing nicely. Now some of us are trying to psych themselves out with where to start. Ashley, how do you want to start this one? Okay, so we're using the titrant, the known, which is HCl. So we're using 0.0122 liters, which is the volume, and you multiply by what? Right, so we don't write molarity anymore unless it's the final answer. You write it moles per liter or liters per mole if you decided to flip that fraction. Because if you write molarity, you don't really know what you're canceling. So you need to write it out as 0.2 moles HCl per 1 liter of that HCl solution. So that shows the liters canceling. Okay, Simon, what's next?
1 mole barium hydroxide over 2 moles.
Good, 1 mole barium hydroxide over 2 moles of hydrochloric acid. And that's the 2-to-1 ratio expressed here. All right, Jaden, what's next?
Yeah, could you put in the molarity, which should be in the form of 1 liter over 0.12.
Good, so this is the last data point we have to use, and we can't write M because M is not really explaining what we need. So we put moles per liter or liters per mole, depending on what we need. We want to cancel moles out since this is asking about volume. So what goes on the bottom, Jaden?
Moles.
What number? What number? It's on your paper. All right, so 0.12 moles of barium hydroxide per 1 liter of that solution. And then that gives us 0.010166, etc. Right? I know my answer from the board. And then how many milliliters is that? Rounded to 6 base. 10 point, actually, where's it? Oh yeah, it is just 10. I don't know why I was going with that many sig figs. So 10 dot, because if it's just 10, you would express it as 1 sig fig. So 10 it is. Okay. There's only 2 sig figs there, accordingly. Oh, see, I made these stuff here. But I had 2.20. So yeah, never mind. It's just for the way it's written here. I'm gonna go with that. It's just 10 on the dot with no dot.
Can you see it?
10, no dot. All right, go ahead and get on number 3. There is enough data, okay? So I'll just give you my 2 cents on number 3. Your job mainly is at some point to get to moles of one reactant so you can do mole ratios with the other reactant, right? Find a way. All right, see reaction out for number 3. Come on. This is a replacement.
Hey.
What's aluminum charge? I didn't know if you were stuck.
Why did we do this? Why did we do this?
Yeah.
You did it.
Alright, here's what we're going to do. I'm going to show you the next steps as some folks are ready to move, but I do want to see this number 3 done in the next couple of minutes. So everybody go to my website, go to Unit 7. I'm not helping you here because I know you can do it. You just don't want to. You're like, I'm tired. I'm tired. Gosh. I don't give in too terribly easily. So I already planned for it. See, I was ready. Okay, go to Unit 7 Docs and go to either the Word file or the PDF. It doesn't matter, they're the same thing. And I just need to show you how to access this because sometimes it's a little finicky with how to get to the simulator. So you are on my website. If you've not made it to the internet, you got to get on the internet first, and then you go to my website. And yes, you're going to Unit 7 Documents, and the Unit 7 document says acid-base web quest, and it's a titration simulation, so you can see how the whole process flows. So Monday, when you have like over $200 worth of equipment in your hand, you're like a piece of cake, okay? So when you click on that, it's going to open this bad boy, and then from here, your job is to go to the virtual titration. The virtual titration has a series of steps associated with it. Some of them are questions where you draw and answer questions. Some of them are steps where you don't actually have anything to answer. All right, let's all make sure that our friends and family are on the right document. Because I see random stuff. So, I think the easiest way to get here is if you right-click. Is this an eraser? I don't know. I can do this right now. I know. I'm telling you right now. It's going to act glitchy, but you got to listen. I currently have an eraser as a pointer. So, if you right-click, so listen to steps. Right-click on that virtual titration link. Hit copy hyperlink. Okay, you have right-clicked and hit copy hyperlink. If that hyperlink does not work in Chrome, it will work in Firefox. So try both. It will pop up. I know in Firefox it's been no problem. You do have to hit allow. You do have to hit allow. So yeah, just agree to all the terms and conditions. You're fine. But it will look like this when you get there. So do not download Adobe Firefox. Just say allow. Just say allow. Please, just You gotta start over. But Firefox will respond. Give it a moment. Why can't I do this?
This type of file format.
It's not, guys. I do this every single year, and I've done this about 50 times today. So calm down. Copy link. Go to Firefox. Look, you hit tab, and then paste, and then it might at first say, oh no, it's Adobe. Oh no, it's Adobe. What do I want to do? I want to activate. Yes, allow. Okay, so at this point, since you're able to move on, I will caution you. Shh. This guy, once he starts talking on the simulator, there's no back button. So if you miss something, you start over. So you've got to be ready. So I think it's really helpful to have the simulator pulled up on one person's computer. Can you turn them down or off?
I don't know how.
It's
You click F5
You get your-
and then you click the top.
just turn the volume down. Okay. So have the document pulled up on one and the simulator pulled up another. Go. Let's go. If you want headphones, use them. If he says some important information, but you should be able to glean most of it from the visuals. Okay. You can move to a live station to get away from people at your station.
It's like
That's what I did. Why not forward?
I'm not sure.
Time is of the essence. No, it should only take you 30 minutes. So you guys were a little slow to go. Alright, focus guys. This is due by when you talk.
Oh, it works. Once you did
thought about it, I guess, this year.
The dude, such a beautiful
Follow the steps.
I was like, how are you already at page 12?
I'm not.
I will only want to when you're asking for